We're continuing to look at problems involving optimization. So we're looking at 19. So it says farmer plans to fence a rectangular pasture adjacent to a river. So here is the river with 3 sides. That creates a rectangular pasture here. So the pasture must contain 245,000 square meters in order to provide enough grass for the herd. No fence is needed along the river, so there's no fence on this side, just along these 3 sides here. What dimensions will require the least amount of fencing? So we're trying to optimize the perimeter, trying to find out what's the least amount of fencing, but yet still retain the area of 245,000 square meters. So we know what we're trying to go for. So this is y, this is x, and so this is also y. It's going to be the same length as the opposite side. So we're trying to optimize the fencing. So the amount of fence is the perimeter. So think of perimeter as adding up these 3 sides. So y plus x plus y, or x plus 2y. So that's our perimeter. Our area is x times y, and we know our target area is 245,000, and we can use this equation to help us substitute and optimize this perimeter, or try to reduce the perimeter equation down to 1 variable, since we're trying to optimize and we're trying to work with this equation. So I'm going to solve for y with the area equation. Y is 245,000 over x. Replace y in terms of x, and now that I have everything in terms of x, I'm going to do multiply through and bring the x up to the top, and I get perimeter is equal to x plus 490,000 times x to the negative 1. Let's go ahead and find the derivative. So p becomes p prime, x becomes 1, and then 490,000 x to the negative 1 becomes negative 490,000 times x to the negative 2. We bring the x squared down to the bottom, and then we solve for x. So I'll move this over to the left side. If I cross multiply, I get x squared equals 490,000. So x equals plus or minus square root of 490,000, or x equals to plus or minus 700. Now, we know that negative 700 is not going to work, since we're dealing with perimeter. Has to be greater than 0. So we're only going to keep the x being 700. So when x is 700, we know that will create an optimal minimum perimeter. So then if we want to find the y value, we can take the 700, plug into one of the area equations, and help us solve for y. So y is 245,000 divided by 700, which is equal to 350. So the minimum amount of fencing is going to occur when x is 700 and 350 meters. So this is going to be the optimal way for us to create an area of 245,000 using the least amount of fencing. Okay, 25. We're trying to find the maximum area. A rectangle is bounded by the x-axis and a semicircle. So we have the semicircle here, bounded by the x-axis. So the equation for the semicircle is root 25 minus x squared. Sits between -5 and 5. What length and width should be the rectangle, or should the rectangle have, so that its area is at a maximum? So we're trying to maximize the area of this rectangle that you see here. And so let's see if we can create an equation for that. So the rectangle has a length that spans this value. Now, it's not necessarily going to always be this length, right? It's not going to always be 8 in this case. So the rectangle, this point xy could be somewhere here, could be somewhere here, could be somewhere a little further out. So we want to be able to represent the length as a variable, since we don't know what the optimal value is yet. So whatever this x value is, we're just going to go ahead and label this as x, right? Whatever that's, it could be 4, it could be 3, it could be 5, but either way, this distance is going to be x, whatever x is. And if this is x, then we know that a rectangle is going to be symmetrical about the y-axis in this case here. So we know that this is also has a length of x. So what that tells us is that we can say that the length of the rectangle, the full rectangle, will be 2x. And then the height is going to be whatever the y value is. So 2x times y. So 2x times y will be the dimension of this rectangle. So or the area of this rectangle. So 2x times y is the area of the rectangle. Now we want to make a substitution, and we can because we know that y is equal to root 25 minus x squared. So we're going to replace y with root 25 minus x squared. And I'm going to go ahead and see if we can get it ready for power rule or chain rule. If I turn the square root into parentheses to the 1/2, notice that these are two separate terms. So I'm going to have to go through product rule and chain rule to get to the derivative. So product rule says f prime g plus fg prime. So f prime, 2x becomes 2 times g, unchanged, plus f, so f is 2x, times g prime. So the derivative for this portion is bring down the 1/2, keep the parentheses, subtract 1 from the exponent, multiply by the inside function's derivative. So now we're going to take this, set equal to 0, but let's see if we can clean this up a little bit more here. So this becomes 20. This is 25 minus x squared, square root. The 2's cancel out, the x's combine. We can combine the negative 2x squared together up top. The negative 1/2 will bring the root 25 minus x squared down to the bottom. And I'm going to go ahead and find the common denominator here, which is going to be root 25 minus x squared. So that means that I have to balance the numerator of this fraction by multiplying by root 25 minus x squared. So I get 2 times 25 minus x squared minus 2x squared. Distribute the 2 through, combine like terms. We get 50 minus 4x squared over root 25 minus x squared. Now we want to find out where this derivative is equal to 0. So we're basically going to not use the denominator at all. It's just going to be the numerator. So when we set the numerator equal to 0, 50 minus 4x squared equal to 0, 4x squared equals 50, x squared equals 50 over 4, reduced to be 25 over 2. Take the square root, we get plus or minus 5 over root 2, but we're talking about a positive length, so x is only equal to 5 over root 2. So if x is 5 over root 2, which is the optimal x value to maximize the area, we can also use this information to solve for y. So if we know x is 5 over root 2, if I plug 5 over root 2 in for x, I can solve for y. So y is equal to 5 over root 2. So the length is going to be twice the length of x. So 2 times 5 over root 2 will be 10 over root 2. Which is the same thing as, if I multiply both sides, up numerator and denominator by root 2 is the same thing as 5 root 2. And then the width is going to be this y value, which is 5 over root 2 or 5 root 2 over 2.